Ernie, what are we doing here? This is a Going Deep?
So we're here to look at peer-to-peer in Windows Vista today.
Excellent.
And I've got with me today, well, why don't you tell us who you are?
Hi, I'm Noah Horton. I'm a program manager with the Collaboration Technologies team here in the Windows networking group.
What are collaboration technologies? What's peer-to-peer all about?
So the idea is that my team, we're here within networking. We originally purely focused upon low-level concepts behind peer-to-peer networking. We then kind of took a step back and said, for a lot of developers, what they care about isn't, server-based computing, peer-to-peer computing. What they care about is, the experiences that their customers are having. And one of the big things that we saw that was kind of a deficiency and hard to do was collaboration inside of software. Where you look at collaborative software today, and there's just not a lot of examples. Mm-hmm. You look at something like Messenger, where there's just a couple of companies who put out Messenger clients, but it's not as big of a set of people as it should be. Where it's great that I can pull up MSN Messenger and chat with my friends, but why is it that when I'm editing a document, it's not easy for me to immediately get in touch with the other people who worked on this document and chat with them from within the context of that program? Why is it that when I'm on a service call with a customer, I can't talk to their actual account rep or something like that? Collaboration is something that should just be basic for software. It should be built in. So we really took a step back and said, okay, let's figure out how we can provide some basic APIs in Windows that'll make it easy for developers to add collaboration to their applications. And really, the natural way of doing that is using peer-to-peer technologies.
So, when I think of peer-to-peer, I think of like Napster or BitTorrent or applications like that. Is that what we're talking about here, where I'm just talking about like file sharing? And, how does it all work?
So peer-to-peer is just being defined as two client computers talking to each other without using a server. The most famous examples so far have been file sharing through things like Napster. And that's certainly one of the areas that we look at as well. But there's a lot of other really interesting scenarios for it where, again, when we're talking about, experiential things, IM is, again, another good example where it is fundamentally something that's going on that's peer-to-peer. What is a server buying you as part of IM? It's buying you that the two of you can get to each other, basically. That's it. You look at playing a game. Well, if you both got a game on both of your computers, why do you need to have a server in the middle for it? You should be able to play directly peer-to-peer. So we look at it from both perspectives. We look at it from the experiential peer-to-peer perspective and from, the low-level APIs, how is the communication done perspective.
So why would I want to, what's in the APIs? Why can't I just have a server today, have a bunch of people log in and get their IP addresses and then have them directly connect to each other? What's wrong with, is that what we're doing, or is there something different in Vista with peer-to-peer?
Great question. So there's a couple of things that are needed for either the scenario you described or for the way that we kind of push doing things, where anytime you want to talk about peer-to-peer, what you're really talking about is you're talking about client machines talking to each other. And for client machines to be able to talk to each other, they have to be able to get packets back and forth. That's the most fundamental thing. If you look at networks today, that's actually a hard thing to do. We've got this stuff like NATs, which were designed to, let all of these machines share one IP address. So great, they can get packets out to a server that's well known, but it's hard to get packets back into them. And when you're trying to go from one set of client machines over to another set of client machines, the other problem is, how do you know what IP addresses to even use for the other ones? Assuming that you didn't have the NAT in the way, what IPs do you use? You don't want to use something like DNS, because DNS was designed for servers that are sitting in the sky. It's built on a model where you have to go out and you have to buy the domain name you're going to use. If you want any sort of security around the domain name, it's based on the U.S. legal system and being able to sue the person who's squatting on your name. And even the additions that have been added to DNS, like dynamic DNS, are really just designed for something like DHCP leases that are terminating, and IP addresses that are changing every day as a result. They're not designed for the real world today, which is that I'm taking my laptop and I'm walking into Starbucks and using a wireless network there. then I'm walking out and I'm on my cellular connection for it, where my IPs are actually changing at such a higher rate. So there's a couple of technologies in Vista that are going to make all of that easier. Where let me talk about the low level actually getting packets back and forth issue first. So most of the problems that occur with that are from the NATs, which is really an artifact of IPv4, where there just weren't enough IP addresses from it, and they were poorly allocated. Where the classic example is MIT had more than China did. So what we at Microsoft have really added a lot of support for and are really evangelizing is IPv6, where the most famous change about IPv6 is that we've gone from 32-bit number space that we had for IPv4 up to 128-bit number space, which is something on the order of one IP address for every grain of sand, somewhere around there.
Nice.
Yeah. So if you want to network sand,
now the IP address is actually more numbers too.
Yeah, they're much longer, which actually has some other interesting side effects I'll come back to. But yeah, they're longer, and it means that now every device can have an IP address, and it's fine. We don't need something like NATs in the middle. Now, the problem is that it's not like we're going to wake up tomorrow morning and every IPv4 router in the world and all that is going to have been replaced. We're going to be living in an IPv4 world for a long time. So Windows has some technologies built into it that are transitional technologies that let you actually use the IPv6 protocol, but have it go over the IPv4 infrastructure. Where the key example is Teredo, which is kind of a consumer-oriented technology that lets you, basically what it'll do is it'll automatically take care of getting through NATs, getting you a world-reachable IP address, and all that sort of thing, so that suddenly your machine that's sitting behind a NAT will just automatically, when you install Vista, end up with this nice IP address that you can give out, it'll work, people can route to it, it's all good. Now, the problem is actually what I just said about you can give it out. You pointed out earlier that these are much longer. It's not where we've got the nice little four little numbers that go up to 256 that are easy to read out. We've now got a ton of characters, and it's almost impossible to manually copy them around and all that. So this is not IPv6 alone is not going to be the solution that lets you call up your friend who's on the other side of the country and say, "Hey, let's play Halo 2 together. Connect to my machine and type in my IP address." 10 minutes later, when you're done reading it over, you'll connect. So we need a solution around that, which basically means we need some way that we can have nice human-readable and transmittable strings that get looked up into IP addresses. Name resolution. Classic
Sure.
name resolution. So as I already mentioned, DNS is not a good solution for this for the same reasons I mentioned earlier. In fact, it's even worse for IPv6 because IPv6 addresses tend to turn over even faster than IPv4 did. So you end up with two options. You basically come back to exactly what you said earlier, which is I go out and I host a server and everybody rendezvous with the server, get IP addresses, we go on. Or you go to some sort of peer-to-peer solution. What my team has really evangelized is a peer-to-peer solution, where there's advantages of both, but the thing is, we look out there at the world and it's like, okay, there are a few companies that can do the server-based solution, and it's going to be fine. Microsoft can do it for MSN Messenger, because we have, data centers of unbelievable proportions where we host all of these rendezvous servers. Oh, come on in. We've got another team member who's joining us, so we'll talk a little bit later. But yeah, they've got these huge data centers that they can run these servers in. When we look at the normal developer out there, they don't have access to data centers like that. And the other problem is that running a data center like that is very expensive. So we don't want to say, okay, every developer out there who wants to add chat to his application has to go start hosting a data center. Instead, we've gone for a peer-to-peer model, where the crux of this is a technology called the Peer Name Resolution Protocol that's part of Vista, which is a completely peer-to-peer system that on the lower levels works in a way kind of similar to the old 6 degrees of separation from Kevin Bacon thing, where the idea basically is whenever I want to resolve a name, I take the name and convert it into a number. And then I know a few people all around kind of the number space. And they know other people around the number space, and those people know yet more other people, and so it all ends up being connected. And we can relay messages through this number space in an ordered way. And what it's really analogous to is that if you use a physical example, it's like saying, I know a few people who are all over the world. I then know a few people who are all over the U.S., about the same number of people around Washington, the same number of people around Redmond, the same number of people around Microsoft, and then I probably know about everybody who's on my floor of this building. And so what I'm really saying is that you know more people the closer you get to yourself. Well, what I can do is when I'm trying to find somebody who's in some part of South Africa, I may know one person who's in North Africa, and I say to him, do you know this person? He'll say no, but I know somebody who's in South Africa. I can relay to that person. The person in South Africa knows more people who are nearby and can relay me closer and closer and closer until I get there. So that's how it works on the fundamental level. But what's really amazing about it is that we can do that without a server, which means you don't have to host servers as an ISV, and as a consumer, you don't have to set up a service relationship. You don't have to do something like we did in DNS of going out and buying a host name and all that kind of thing, a domain name rather. And it also means that we're in a world where you can actually start registering names programmatically, where when I'm not having to set up that relationship, what I can do is I can just have my application like Halo 2 actually automatically publish a name, where when it starts up, it can just automatically say Noah Horton's Halo 2 endpoint, and then my friend can resolve that as immediately. And he doesn't have to know what machine I'm on. He doesn't have to know anything like that. He just knows the name, and he can connect. So that's kind of the technology we've added at the low levels. We've then added some other interesting peer-to-peer technologies where once you've got a technology like that where you can find two people, and once you can get them to rendezvous, the next question is, well, what if you have multiple people? It's natural if I'm talking about something like Halo 2, let's have multiple people in this game, not just two. So we've got a couple of technologies, graphing and grouping, which are native code technologies, and then we have the Indigo Peer Channel for the Windows Communication Foundations, which are both mesh communication technologies, which really means that what we do is instead of having a data transmission model where either everybody in the game, all 8 people, has a connection to everybody else in the game, and so everybody ends up with all of these connections, and you immediately saturate your pipes, or a connection where you've got one server in the middle and you get a star topology. We have this kind of partially connected mesh, where if you've got 8 players, each player may be connected to 2 or 3 other players, and then whenever there's a message sent, what happens is I send it to all of my neighbors, they send it to all of their neighbors, and so on. And in just 2 or 3 generations of retransmission, it's gotten to everybody. So it's a very, very efficient way to use your bandwidth and communicate with tons of people. And these technologies will actually scale up to thousands and thousands of people. So that's not really a scenario for gaming. But it is a scenario for looking at Peer Channel. Imagine you're doing something like you need to push stock prices around, or some sort of information like that. It's pretty easy to build a mesh that's a very large mesh, and we'll just propagate that data out efficiently.
So something I'd worry about with that as a developer is if I'm pushing like stock quotes or even gaming data across multiple people, are they going to be able to manipulate that data as it goes through their computer and gets routed out to someone else?
What our general model around that is, and the model actually changes a little bit between the different technologies. So if we had a little longer, I'd go into a deeper dive on each one. But the crux of how we handle that for the most part is either you have a mesh in which people are authenticated by password, and you've kind of said everybody's going to be trusted inside of this, and they can do that, but we're not just letting everyone in. Or you have a strong security model where we're using cryptographic identities, where the way that it works in that case, and this is a much stronger model, is that when I create a group, I become the master of the group. I'm the owner of the group. And what that really means is that I create a cryptographic certificate that's a self-signed cert, the public-private key pair. Then what happens is I start inviting people into the group. When I invite somebody in, what I do is I take their public key that they give to me, and I create a new certificate, which I sign with my own private key that says, yeah, this person is really supposed to be a member of the group. What then happens is they can use that certificate to join the group, because it's very easy to then authenticate anybody in. All you have to do is you have to look at their search chain and say, okay, does this route back to the root owner, the group owner, and you can confirm that they have the private key associated with the cert they're presenting. So it's easy to bootstrap people in, regardless of whether the original inviter is still offline or is still online, which is a big deal. It makes a group much more useful if you can have people coming and going as they wish. And then what we do for the actual data integrity is the records that we send out actually get signed by whoever created the record. And that way, if anybody else tampers with it along the way, we're able to, see that happened, and we validate it, and the app doesn't have to worry about trying to handle it themselves. We also have a permissions model so that you can actually say, okay, this person is just a member. It means that he can publish his own records. He can't touch anybody else's, though, and that sort of thing. Versus this person is an administrator, and not only can he publish his own records, he can actually overwrite other people's records and modify them and stuff like that. So it's a pretty robust model to really let you do some very sophisticated things without having to go through all the trouble of trying to build your own mesh communication algorithms, which is very hard. A lot of weird corner case problems of, what happens when you've got 4 people in one company, 4 people in another, they're in a mesh, then you have the link between the two of the companies go down, and then it comes back up. How do you detect that partition happened? How do you repair it? A lot of weird stuff like that that's actually very difficult. So we take the trouble out of that. We take the trouble out of optimizing that mesh so that, all of those neighbor connections we have are very efficient ones. So we've solved that for you, and we've just given you a wholesale solution that you can use. So those are really the technologies that we have at the peer-to-peer communication layer. Those are the things that could be generically used for all sorts of applications. Now, as I said at the beginning of this talk, one of the things we did is we stepped back and said, let's look at the real scenarios. Let's look at collaboration. That's the biggest thing that a lot of apps want to do, whether it's game playing, whether it's chatting, whatever. Let's figure out how we can make that easy for developers. So what we did is we built a couple of technologies that are built on top of those low-layer P2P technologies that are reusable collaboration tools that you can put into your own applications. Where the first technology I'd mention is serverless presence. Where the idea behind this is I've got my buddies, the people who I communicate with a lot, and it's a dangerous world out there. I want to be secure with these people in general. So we're going to exchange cryptographic identities with each other. I'm going to have a nice contact card, a V card, that actually has my public key in it and everything, and I'm going to share it with my friends. This is becoming more and more common. We're pushing that into the OS, that you have those contacts, those buddies. What's interesting then is that now that we've got that cryptographic info for them and their public key, we can actually start tracking their presence, just like in Messenger, whether you're online, offline, busy, etc. We can start tracking that stuff across the internet without using a server. Now, the way it works is that basically, when I first log into Vista and I first run a collaborative app, I get to choose whether or not I want to participate in this sort of a system. If I do, what it'll do is it'll use PNRP to publish a name for myself that is generated from my contact, and then all of my buddies can resolve that name whenever they start up and form a connection to my machine. We then can exchange this presence data without ever having used a server. What's then cool is that we don't just do very basic presence of online, offline. We do a couple of rich things. One is called capabilities, where the idea behind this is, okay, I'm trying to find my friend Todd, but I want to play a game with Todd. So Todd may have this is Todd Manning over here. I want to play a game with Todd, and Todd has 10 different computers. So I don't want just any one of his computers. I want the one that actually has Halo 2 on it, so that I can play with them. Well, we let applications register themselves as capabilities on a user's machine, so that when their buddies connect, they can see, hey, this machine can handle a Halo 2 session, it can handle a voice over IP session, etc., etc. So you get this rich concept of capabilities. Then, if one of those applications is actually running, like Halo 2, it can push rich presence information, which we call presence objects, where what that is basically it's arbitrary data that it can push across, and on the other end should be interpretable. Where for Halo 2 it might be something like, not only does Todd have Halo 2 installed, he's currently playing it, and he's playing this particular level with these particular people. If you look at Xbox Live on the 360, it's very similar to what you're seeing there, where you can see your friends, see what they're playing, etc., etc. So that's really cool. But so great, I've seen that Todd's there. Now I want to do something with him. So the next technology that we have is what's called application invite, where the idea is that if Todd has an application installed like Halo 2 that registered itself as a capability on his machine, and it's done a little bit of additional setup, it can accept remote invitations for this activity. So the way that this works basically is, on my machine, I say, I've got the application that's using these APIs. It says, okay, here are all your buddies. I select Todd, and I say, invite him to Halo 2. My system can call this generic infrastructure that says, create an invitation to an activity, and put a little data blob in there that might have some information on, who am I, what are my IP addresses that he wants to connect back to, all that kind of stuff. And it's going to get sent across the wire to Todd. On Todd's machine, Todd may be sitting there, actually working and playing Excel while I'm slacking off and playing Halo 2. So he doesn't have Halo 2 running. What'll happen is there's a generic listener in Longhorn that's going to catch that invitation. It's going to parse it. It's going to say, oh, this is an invitation for Halo 2. I know about Halo 2. I've got that installed. It's going to pop up a little piece of UI that's a little bit of toast, like what you get from Outlook, that says, Noah's invited you to play Halo 2. Do you want to play? Yes or no? If you say yes, it's going to go and automatically start Halo 2 for you, and it's going to pass that data blob to Halo 2, so that Halo 2 will know, oh, okay, I just got invited by this person, I can connect back to him, and we can start playing. Mm-hmm. So this is really cool. This is a big change. Almost all the time in the past, going back to the original example of, Halo 2 across the country, not only did I have to, figure out what my public IP address was, not only did I have to read it to him over the phone, we both had to have Halo 2 running at the same time. Now suddenly we've gotten to a point where, I just can invite one of my buddies to an activity. And this is generic for Windows. This isn't through some custom IM client like Messenger or something like that.
Now, is the default... that sounds incredible. I mean, it's really amazing. A concern immediately that comes up is the tendency for Windows to give people options to not be secure. So if I start a non-secure network, that means I'm going to get toast that's going to be spam. It's going to be the same kind of problem that we get with NT with the Windows messaging system of the past.
Yep.
So by default, do you enable secure communication? I mean, why even give them the option to have an unsecure peer-to-peer network?
So,
just out of curiosity, I'm just asking.
It's important to note that when you set up those buddy relationships, you have to authorize the buddy relationship. And you can set up the infrastructure to just allow for your buddies to be able to send you invitations. We provide that through an API. But then also there is, since it is tied, the toast is tied to a particular piece of UX, inside of that UX you can also turn off the ability to receive those invites if you'd rather just not have it at all.
Okay.
We do, and by default all of that is turned off. So by default the system is secure from unwanted toast, but if you decide that you wanted to turn on the system, then you can authorize particular individuals to send you an application invite in order to do it.
Fantastic. I mean, I just wanted to stress that just because it's a new kind of paradigm that we're doing here.
That's right.
Secure by default.
That's right, and security is key. And I mean, the other thing that we'd emphasize is that all of those buddies who we're talking about for serverless presence and everything are people who you've exchanged cryptographic data with. And I mean, we can encrypt all those connections. We can authenticate. Those are really secure connections. Now, we have a third technology, which is what we call people near me. which is the same sort of paradigms, but take it out of the internet, where it's, you know, all of my friends who may be all over the world, and let's just talk about the people who are immediately around me. People near me is saying that I can see who is on my local subnet, basically, which is generally a good indicator of people who are physically close to me. I can see them, I can see their presence data, and I can invite them to activities the same way I would a serverless presence buddy. So, you know, the scenarios where this becomes really interesting is, you know, you walk into a meeting room and you all want to be collaborating on some sort of document. Well, maybe these are people from another company who you don't work with often, you know. You just want to invite them in, and they're nearby you. So it's a very natural paradigm to just have that exposed to you. Now, that's a different case where that is a slightly different security relationship, where, you know, you don't have that cryptographic data in advance and everything. So it relies a little bit more on some social mechanisms of, you know, if I'm going to invite you to an activity, you know, you're probably going to want to have line of sight with me and say, hey, Noah, did you just invite me to something, you know, before you click on the toast. But, you know, it's pretty easy to have those mechanisms when you're in that sort of an environment. And it's also restricted so that we're only going to accept those unauthenticated connections if it is somebody on your subnet, and not if it's somebody across the country. And then finally, we actually let you control this separately from serverless presence. So just because you're doing, you know, the really secure cross-internet serverless presence doesn't mean that you have to do people near me.
Now, can you do a serverless? Can you use serverless presence in conjunction with servers? So, for example, an obvious example, a cool scenario would be virtual Earth. Like, I want to know where Ernie is because he owes me some money, and I'm going to track him down. No. So, I mean, do you know what I mean? So, in other words, that kind of game. So I could play like, you get online, you're somebody I care about in my little peer network, and I want to know where you are. I know it's different than what you were just talking about. It's more a second example you were talking about.
That is a really cool scenario, and that is exactly the sort of thing that we'd encourage a third party to develop, actually, where because we let applications push those rich presence objects around in serverless presence, it's easy for you to go out and write an application like that where you've just got a little service that runs on your desktop and will publish your virtual Earth location to all of your friends. Let them map it out. That's the sort of stuff that we've suddenly made easy for developers to do.
Excellent.
So,
what about the case where I'm not like in a meeting room, but I'm at Starbucks or something? Or an example, I was down at a customer site last week, and I had to share my PowerPoint slides with everybody because they were like 10 megabytes and, you know, lots of huge pictures. So I couldn't, like, my option was to take a USB key and share it around with everybody in the room. Is it possible to use like just a wireless network that isn't set up for, I mean, is that still, you know, the sort of ad hoc wireless type thing?
well, that's an interesting segue. Let me use that as a segue here. So, serverless presence and people near me, and actually PNRP and most of our technologies will work actually in an ad hoc network. They're pretty much all network agnostic. That's one of the cool things with PNRP is it'll work. You know, you're disconnected on a plane all the way up to, you know, it's cross internet. And the same buddy who you have across the internet, you know, serverless presence will still work for him even if you're on a disconnected network. But what's then more interesting for the exact scenario you talked about of sharing files inside of a meeting room and everything is actually an application that we're shipping in box, or that's a neat experience that's part of Windows. That is tentatively called Windows Meetings, I believe. Oh, okay. Name may have changed. I'll let him talk about it. But I'm going to turn it over to Todd Manning, who's the master on this experience here.
So Todd, what do you do? What's your deal?
So I'm a program manager in the Windows Collaboration Technologies team, and I'm responsible for all of our experiences and everything that we build inside of Windows that's built on top of the platform that Noah was talking about.
Okay.
And just like Noah was saying, we notice that there's a lot of different problems that developers run into when developing a peer-to-peer infrastructure, and especially developing a peer-to-peer infrastructure that focuses on collaboration. We also noticed that with users and the experiences that they had, they encountered a set of different problems around collaboration as well, you know, at the UI layer. And so what we've done is we've actually created an experience in Windows. It's officially kind of codenamed Windows Collaboration, and it's available in the December CTP and working, so I encourage you guys to check it out.
Absolutely.
And but the the entire experience is focused around how do we make collaboration in a face-to-face setting a lot easier. And collaboration entails many things. I think it entails both the file sharing that you talked about a little bit earlier, but then also being able to share out an application. For example, my PowerPoint slides. Today, we all have the laptops in front of us, or maybe sometimes there isn't a projector in the room, and what I'd like to be able to do is just be able to project my slides to the other PCs. And so that's what this experience really enables you to do, is it allows you to share files really easily, it allows you to share an application really easily, and then collaborate on that application by handing control back and forth between people, and allows you to easily join and set up meetings in sessions, collaboration sessions, whether you have a network or not. If you don't have a network and your laptop supports an ad hoc wireless card, they'll actually put the computer in ad hoc wireless mode and associate that network with the session itself so that people can actually start to collaborate. Cool. So it's a very cool experience, and we're very excited about it. And so I encourage you guys to check it out. It uses all the different technologies that Noah was referring to earlier. It uses grouping, the mesh-based communication topology, communication mechanisms. It uses PNRP in order to do the name resolution, to find the sessions that are going on in your nearby subnet. It uses the people near me in order so you can explicitly invite people. It uses that application invite so that you can pop toast on other people's machines in order to invite them into a session. And so it's very exciting. We're very excited about it.
So if you had a meeting of 15 people and the slide projector went down and you had to create this ad hoc peer network, so you're talking about, how long would it take?
It takes 2 clicks, so it takes about
Beautiful.
4 seconds at the most in order to do it. So you simply fire up the experience, type in a name and a password, and you're off. And other people can join implicitly by looking for the sessions that are going on their nearby on the subnet, and just type in the password and join, or they can be invited explicitly through that people near me app invite mechanism that we talked about earlier.
Very cool.
Now, you'd mentioned ad hoc wireless.
Mm-hmm.
I've never actually used the ad hoc wireless capabilities. I mean, what is that? Is that connecting without the actual network there at all? Like my card directly to your card, or does there have to be something in between?
Yeah, that's exactly right. So in the wireless world, there's actually kind of 2 different kinds of network topologies that go on generally. The first is a WAP, which is wireless access point, where there's some kind of router, hub, switch-like thing that we're all connecting to over the wireless network. And then the other way is that, all of my wireless cards are able to go into what's called ad hoc wireless mode, where they become both a transmitter and a receiver, in a kind of like a peer-to-peer ad hoc wireless session, and they can communicate over that. And so what we do is we actually determine whether or not you have network connectivity on your local LAN. If you have it, then great, we'll create the meeting on that particular local LAN. If you don't have network connectivity, then we'll go ahead and create the session on its own ad hoc wireless network, and we'll actually make the SSID of that wireless network equal to the session name, and then we'll utilize the password or derive the security key that's used in order to encrypt data on that, to encrypt the layer 2 ad hoc wireless network. And then on top of that, of course, we're using the communication infrastructure encryption that Noah talked about earlier.
It's very cool. I mean, it's obviously important to stress that this is going to enable just crazy cool applications.
Yeah,
I mean, and that's
most definitely.
It's really an awesome new feature in Vista.
Yeah, the peer-to-peer network was crucial in us being able to create this experience, because it allowed us to function not only in the meeting room or in the conference room, but also up to the internet as well. And so it's been a great technology and a great platform to build on for creating this brand new experience in Vista.
So up to the internet. The last sort of thing that I always want to do with peer-to-peer is like share my photos with my parents or something like that. And maybe I'm not connected at the same time there as from an application. They're back on the East Coast, 3 hours difference, and I am not going to be there to accept an invite to a session. Can I share my photos out using peer-to-peer over the internet somehow? Or because you mentioned the sort of DNS type scenario before, where we're not using DNS anymore, but I mean, can I just connect to someone's peer name through IE?
Yeah, so that's actually one thing that we've worked on as well, as we've incorporated PNRP names into the getAdderInfo API. So what does that really translate to? It really means that what I could do is I can type in a slightly what we call is a DNSified PNRP ID, so to speak, into an Internet Explorer and be able to connect to their machine directly in order to serve up things such as pictures. So one of the demos that we did at the PDC was we showed exactly that, where I'm able to type in a .pnrp.net address into an Internet Explorer window, and that resolved to a machine underneath the covers utilizing PNRP to a makeshift to a lightweight web server that we had there that was serving up pictures. And so that's one of the new features that we have in Vista, and very excited about that one too.
Very cool.
You could easily build an application such as what you were talking about with the peer networking APIs.
So now let's talk about really briefly, and because I have to roll, and maybe you can just continue the interview and bring me my camera back.
Sure.
If you want to. So you implement this as part of the new networking stack. So where is this implemented inside of Windows? You're down in the kernel, or are you a component? I mean, what's going on? Where is the peer-to-peer network implemented in Windows? That's my question.
It's actually,
architecturally.
It's actually above TCP/IP.
Okay.
So it's at basically the application layer.
Okay.
And
Just
that's where it is.
good things to talk about.
Yep.
Innards of Windows. We like to do that. So I'm going to step out. Pilot over here, Ernie Booth, who we didn't introduce, but everybody on Channel 9 knows who he is. Hey, you guys, thank you very much.
Thank you, Michael.
So
Awesome stuff.
Back to you. Do you guys have any peer-to-peer stuff that you can actually show us today?
So actually, unfortunately,
we're in the middle of a build upgrade cycle. So we built
ugly.
a brand new build for the December CTP last night, and so all of our machines are being. So all of the machines with the new Vista experience are actually being upgraded right now in order to test out that build and make sure it's good to go and ready to go.
Yeah.
So
anybody who wants to see the install screen, we can demo that.
Yeah, we can.
You know, that's unfortunately.
So now, is there any place that people can go to get more, peer-to-peer stuff?
So there's a couple things that people can do. One is install the December CTP. That's probably the number one thing you can do. It's all there. You can play with all of it. Then when you want to find more resources on it, we do have a URL that you can go to that's very easy. It's just www.microsoft.com/p2p. Pretty simple. That's kind of our clearinghouse for all the information on peer-to-peer in Windows. It's got linked to some great papers, all the developer documentation, all that kind of stuff. There's also some blog links on there and some stuff like that. So that's the number one place I'd push you to. The other thing is that if you've got general questions, there's an email alias you can send to. It's peerfb@microsoft.com, PEERFB at Microsoft. So please send us questions, comments, whatever.
We also monitor news groups quite regularly. So if you look at the Win32 Programmer Networks news group, then that's one that we monitor quite a bit.
Now, are there people actually building peer-to-peer apps today already?
Yes.
Yeah.
Yep. So actually, one of the first apps that was released on top of the peer-to-peer infrastructure was an app called 3 Degrees. So Microsoft released that one a couple of years back, and then also Corel Grafigo 2 utilizes the infrastructure in order to do collaboration. And I know that we've been working with several other different partners, and Noah's been working with them quite closely. So yes, there are a lot of other companies building peer-to-peer applications using these APIs, and we look forward to working with them to release something, at the right times.
Yeah. We hope to have a couple of other partner products there at launch that'll show off some of this. So it'll be there. The other thing that I'd mention that's kind of interesting is we have this Windows Collaboration experience, and part of what's going to be cool about that in Longhorn is that it kind of is going to raise consumer expectation. Where this is going to be the first time that something like ad hoc wireless is actually useful or usable and everything. And once users end up getting a taste of what you mean, I can actually do something with somebody who's right in the room with me, something that natural, the demand is going to be there. So that's part of why it's cool that we have experiences like that. Is it's going to raise the consumer demand. It's going to make people want to spend money on upgrading third-party applications to have these functionalities.
Yeah, so you'd mentioned on the plane before using your ad hoc wireless once the FAA approves us doing that, I'm sure. So that'll definitely be a cool experience to be able to work with someone else on the plane or play a game or something like that.
Well, and that's part of what I think is cool too, where one of the things that I always like to talk about actually is that part of why I think people tend to like their cell phones, if I could pull mine out here, people like their cell phones more than their PCs in some cases, because the thing just always works, I can call my friends from this, no matter where I am. It always works. I just don't have to think about it. And that's part of the thing with the PC right now is that, there's been so many experiences where it's, I can chat with somebody as long as the network's configured properly and as long as I can reach the server and yada, yada, yada. And that's part of what's cool with the peer-to-peer stuff, too, is that, it works in all of these different scenarios. It works the same way everywhere. Just when consumers get a taste of, it works the same way everywhere I go and just works. It's a whole new world. It's how computing's supposed to be.
So our channel 9ers go download the December CTP, install the Windows SDK. Where do they start from there? I mean, where's the first place to start?
We've got some great samples in there. Show off how to use every one of our technologies.
Graph chat.
Yeah, Graph Chat is the canonical example. That'll show you how to use a lot of the stuff. Just start playing with some of the samples and start thinking about your own experiences. Look at your own application and all the stuff you could do. Think about, what do you do when it's easy to connect two machines together, It's a new world. Think about how it changes your experiences.
Great. Thanks a lot, guys.